We agree.
What? What?
Sorry.
Oh, damn. I don't really. That was funny.
Take notes as we discuss. So, if you need to write on something, that's
Look at their board.
that's good. I want to encourage you to write things down as we go over stuff. There was some people saying that sometimes things aren't explicitly explained, but if we pick up certain parts of our discussion that lead to better understanding about what's going on, you might want to jot those down for future reference. Okay. All right, so last time we started, everybody picked a presenter from your group, so someone different should be presenting this time. So let's take a look and start with. Are you presenting?
Yes.
Okay.
Yes. All right. So this is our group work, and then we came to the conclusion that they are exerting the same force. And first, a little background information that if an object's not moving or it has constant velocity, the net force is 0, right? So we are assuming that they're not moving at all, they're just standing still, leaning on each other. And right here my forces are, we got the force of gravity going downwards, normal force by the earth, and then the normal force pointing upwards by the surface. And right here we have Sam's force exerted that way, and Shirley's the other way, and they're equal. And we have it because the net force is 0. And although that Sam's mass is higher and Shirley's is lower, they are still exerting the same force since they are not moving, and the net and the opposing forces are equal because the net force is 0. And here I wrote down little equations. Here's I labeled this FP1 for force push, and FP2 for Sam's push for Shirley's, Sam and Shirley, and yeah.
Thank you.
That is,
So maybe next group, could you quickly explain your?
We said that Sam and Shirley are exerting equal forces on each other because since Sam has a larger mass or whatever, is bigger, Shirley has to exert the same amount of force in order to be equal with Sam. And Steven is going to explain the three-body diagram.
Oh, okay. Well, since I kind of saw it as like since they're both exerting force on a single point, I decided to make it so there's just one single point. And because they're exerting force on a single point, I decided to add their gravities together, whatever, or their mass together. So that's why the normal force is so big. And then I thought, since they're leaning on each other, then maybe the gravity is split between them.
Next group.
All right. Hey guys. So what we have here, we kind of agree with Steven, at least our full body diagrams do. Here we have the dot, which is basically the point between of contact between the two people, Shirley and Sam. So what's happening here is up, or FN, force normal, is being exerted by the surface because they're standing on it, obviously. Secondly, there's the force of gravity from the earth is acting upon both of them equally because they are not moving, and they're not moving. One's not, it's not tipping over either way, and from that, because they're leaning, their vectors are angled. But because of what we learned before, we could draw the same perpendicular full body diagram by drawing what adds up to make that vector. And if you add this force, Sam's gravity down, Sam's gravity, and Shirley's gravity down, it equals the force, cancels out the force of the surface by up. And also we wrote one of Newton's law, for every action there's the opposite and equal reaction, which is why even though Sam and Shirley are different sizes, like they're not moving just because of they're exerting the same amount of force. So yeah, that's what we
Okay, thank you. All right, let's try to get maybe in 60 seconds or less. Could you just explain what you did and yeah, and why, so we can get our discussion going. Sorry, 60 seconds. The next group, Jeff, is your group.
6 seconds. Alright, so they're not moving, so that means it's supposed to equal out. Sam's pushing this way, Shirley's pushing that way. They're both equal. Not moving.
Okay,
0 net force.
got it.
Let them all go.
We'll let everyone go, then we'll have questions real quick. Yeah,
60 seconds.
Alright, we had the same thing. We had equal forces. Sam is going that way, Shirley going this way. So they cancel out, so nobody's moving.
Okay, great, thank you.
Well, we said, since Shirley and Sam, they're exerting the same forces.
5 minutes.
Show the other people too. Yeah.
Yeah, they're equal forces. Because since they're like at the same like they're not like tilting or anything, you know, like going sides. So they're both exerting the same force, even though Sam's heavier or has a greater mass. And then we drew this, which said that they're getting pushed on the ground. Like Arthur.
They're not moving.
I mean, I get it, but like, I don't know the words. Okay.
Okay,
Yeah.
thank you.
Nice job.
So, Sam and Shirley exert equal force, and so Shirley's force going this way, and Sam's going this way, and then the natural there in gravity. And so we have these two forces that have the same, they're pushing on each other the same thing. That's why these two over here cancel out, so that they're equal.
Okay, all right, thanks. Okay, so you can see we have different types of free body diagrams and some different explanations. So maybe some of you have some questions to ask each other about your thinking. Okay.
We get points for answering questions.
You get discourse.
I have a question
Okay.
for these two. How is gravity being exerted in like an angle direction?
Can you just answer that, Steven? You wouldn't answer that, buddy? You would handle that one?
I don't know. I just changed my picture.
I would answer it as basically, if you think about it, these two, if you think about it just like towers or something, it's like they touch, right? It's gravity that's acting upon them, not the actual people themselves. Like if you're leaning on somebody, you're not just like pushing like your back into them. Gravity is the one that's making you fall back and leaning. Therefore, it's gravity that's exerting the force on the people, which causes this diagram instead of the actual people themselves. So, yeah.
I don't know, Mr. Nerdy was talking about yesterday, if gravity was exerted this way, we would be moving this way all the time, but if it's exerted down, we would just be pushed down rather than at an angle.
See what you mean. Let's see about that.
So the two groups that drew gravity at an angle, what do you think about that comment?
That's interesting.
Actually, that's true.
So maybe if we flip our diagrams.
That's true.
What's true?
Gravity is always straight, or for the most part.
Pulling down.
For the most part, straight down.
I totally agree.
Yeah.
More about part.
Unless we get out into space and things like that. But like here on Earth, yeah, towards
Towards the center of the earth.
Yep.
Which is down.
Which is down, straight down.
Straight down.
Good question.
So we're saying we're wrong.
Yes.
We're finding flaws in our diagram.
Actually, I would flip it around.
That's kind of the discourse.
Learning
So we're
experience.
through the discourse, we're trying to identify what kind of thinkings going on, and you know.
But I think they're combining the forces of gravity that's going down plus their forces that are pushing against each other to create like
Well,
I mean, I don't know, that's kind of what I interpreted from you guys.
I see what you mean. Like, I feel like here, this is the force of gravity here, because it's straight down, right? And this is the force of them acting upon each other, which is probably what has happened.
I think we took the drawing too literal. We forgot the gravity does go down. So I think that if we flipped our drawings upside down, then that would be more accurate.
Yeah, we're right.
Flip it upside down.
They cancel out. Yeah,
Comments?
it does make sense. Yeah.
Questions
Oh,
about
a
it?
question for Daniel's group. In the picture, it looks like they're pushing kind of like this against each other. Why do you guys have it going horizontal?
I'm just a bad drawer.
Well, we were just showing how they would cancel out. It's not really accurate
Yeah.
which way they're going.
Yeah.
How did they cancel out?
Because
I thought Sam was bigger.
even though Sam is, well, then aren't we all wrong if Sam is bigger and they don't cancel out?
You never said Sam was bigger.
They say
Oh,
But we can't get confused of mass and forces. Like, even though they have different masses, even if things have different masses, they can still exert the same, like, force on each other, right?
Yes.
Which, I mean, a lot of us seem to agree that they're exerting the same force, but they're different masses, right?
What do I mean? Because I mean, like, because Sam has more mass, he could be pushing less with the same amount of force. But then Shirley being smaller, she'd be pushing harder,
Yeah.
and that would equal out.
Using more effort. I mean, yeah.
And the angle that she's at also.
Wait, so when that
Mr. Henderson, is there an angle that they're touching?
Yeah, that's an interesting question, right? I mean, the
Or should she's heavier.
yeah.
She has to use more.
Force
I got the picture. So they are. I mean,
But they wouldn't stand
they're back to back, and it looks like they are touching, which
Are they
it looks
touching?
like, sorry, they are touching each other. And really, what I want you to focus on is what direction are those forces acting in. And so I want you to think about that. What force is the direction Sam is pushing, and what is the direction Shirley's pushing? Should we get a frame of reference?
Sure. Are we gonna do it like in
So let's get a frame of reference.
Maybe we should.
Should we lean on each other?
So if we have, Shirley,
I think we should try with real people.
We should get real people to do it.
oh, should we get real people?
Yeah.
Yeah, get a small person, get a big
Okay,
person.
I'll do it.
I'll
do it.
Sam and
Who's the smallest person here? Who's the
Mary
smallest?
Ross, that's perfect. So why don't you guys lean back to back?
What about Arlene?
Get on it, she's no.
You just want to. Thank you. So let's see how you guys lean back to back.
Shirley.
And then
Don't move.
just like that, and don't move.
No
And
force.
So what direction, Sam, does it feel like your force is in? No, you guys have to lean into each other. Yeah, there you go.
No surprise.
I
Okay,
think
so-
Mary Ross got to lean lower.
Yeah.
So what direction does it feel like your force? Yeah, so what direction does it feel like your force is in?
That way.
Is it?
I know.
Yeah. And how about Mary Ross? What direction does it feel like your force is in?
Backwards.
So,
Okay, that makes sense then.
does anyone have any questions for our presenters about
Nope.
force?
It's like inside an angle or like straight, like leaning or like angle down, or is it just horizontal?
Do you feel like you're putting less energy into it than Mary Ross? I feel like you're putting more into it.
So it's not. It's like
Yeah.
more on family here.
It looks like a reason. No.
All right, so let's get back. So I heard energy and I heard force. So let's think about the force that your back is exerting against Mary Ross. And so Kadi asked, what? Say
Yeah,
again.
is it like horizontally, like back and behind you, or is it angled? Or is there a certain angle to it? Is it angled?
Feels like your angle.
that's what I was saying.
The angle.
That's what I was saying.
I have a question.
So let's try.
Yeah.
Yeah, question. We have a question.
You're wearing purple.
So in the picture, I don't know if I'm like going crazy, but
Yeah.
does Sam look like he's
Sam, thank you, Mira, thank you.
he looks like he's like 90 degrees from the 90 degrees.
Yeah.
Or, yeah.
So maybe he looks like he's 90 degrees.
Yeah. Is
Right. Maybe because he's so much. I don't know.
He just looks like he's 90
It's a
degrees.
good observation. You have a question that goes along with that?
No,
Or
I'm just asking if they look.
if he is 90 degrees?
Yeah.
On the diagram, I would say he is not.
Okay.
I would say he's angled a little bit. So there's this question right about the angle, and so hopefully we can take a quick look at this net situation and decide whether or not, well, maybe this will help answer the directional component. So we need a couple people, volunteers.
Ooh, ooh,
All
ooh,
right.
ooh.
Hadi.
I want to learn.
I'm gonna get Lester since he's right over there.
Ah.
Sorry, you guys can try this some other time.
Because I'm small.
So this is the
Because I'm
fourth
small.
exercise. Don't push
Yeah.
too hard. You guys might break them. Okay. So. No, just kidding. Don't start yet. Don't start.
I get it.
Kimberly,
So,
can
yeah.
I get one of
Okay,
your,
so
get one of those boards,
let's
round one?
let's zero out the first answer.
Clear.
Round one.
Round on.
Hold on.
Say one though, it doesn't work.
I'm gonna. Why don't you guys just touch them?
I just got that.
I know it's Valentine's Day coming up, but just.
Okay.
Okay. All right. So I'm gonna hit collect, and then we're gonna start looking at seeing what kind of data. So why don't you guys push against each other? Can you guys see that? Maybe you should.
Battle.
You two can spin.
Oh, yeah.
Guys, we can.
So-
Guys, how we go?
Kai's winning, Kai's
Oh,
winning.
side again.
Yeah, maybe.
Should we try this? Can you guys see that? Maybe we should change our scale.
That's a side curve, yo.
Hey, you wanna go to 800?
That's why you can't.
Okay, let's try it again. Ready?
Yeah.
Okay, go.
Go for it. Oh, winning.
Why is
Somebody winning?
Yeah.
All right, that's okay. Calm down. We can play this later. Thank you, demonstrators. We can put it down.
Clap for demonstrators.
That's perfect. All right.
Kimberly, you look sick.
I heard a comment here that somebody was.
I'll do it later.
Somebody was what? Someone was winning?
Nobody, it's the same.
It looked like Patty was pushing harder, but it was the same as the rest.
I let him even push like that more.
It looks like if you flip one, it'll be exactly the
Right
same.
there, I let him.
Yeah.
It's the metric.
Because the thing is that.
Spell it now.
So what do you think now about the force on Cotty by Lester and the force on Lester by Cotty?
Cotty on Western.
Do it.
They're equal.
Could you guys, if I made you, well, okay, how about this? Why don't you guys have your pens real quick? Could you maybe real fast just erase a part of your board, and if you could draw two free body diagrams, one for Lester and one for Cotty. And let's, to keep things simple, let's only do the interaction between the two of them when they're pushing against each other. Put it away. So real quick, in about 2 minutes.
Keep erasing. Here.
Any eraser?
Well, I guess, wait, are you clarified? Is it two free dot by one representative, one
Where's our eraser?
Yeah.
Maybe that
Eraser be that one.
Yeah, because like, okay.
Okay, then
Yeah,
you're
this is
erasing
that.
that.
I'm sorry.
Can we erase it all?
I'm
I know.
sorry.
That was my plan.
Force of
Equal.
Lester against force of
Which
Cotty
direction was
against
Lester pushing?
Lester was pushing. I just want to make accurate.
Could you give that force a name?
Yeah.
force of Lester against
Yeah, we were debating yesterday.
Okay.
So we decided yes.
Yeah, I just thought about it. I just realized
Make sure you name your forces.
Right.
You need 2 diagrams.
Oh, yeah.
Because how many people do we have? Yeah.
Gravities aren't the same.
oh, normal.
Okay, so probably another 30 seconds, and we'll. And when your group is done, would you face the center and put your whiteboards back down so we can make sure you're done? You're ready.
That's why it all cancels out, right?
I find it interesting. Think about it, like the gravity is always gonna be equal.
Oh my god. Normal force and gravity.
Well, they're always gonna be just less.
That's
Like, if they were on a slope.
Okay, so once your group is done, would you please face center? Put your
It wouldn't be the same.
Put your boards on the floor so we can see them. And so we can see what everybody wrote.
What did you say?
Once they get down, okay?
Oh my, you guys so inappropriate.
Rich, you took that in an inappropriate manner.
What are you talking about? You said that.
Make sure you label your forces and tell us what they are. We'll probably just, I mean, we probably won't have enough time for everybody, but we just spent, well,
You do fast.
Same question.
almost there. Yeah, so while we're waiting, just take a look around and see what other people, other groups came up with. And let's compare. And maybe while you're looking, you can think of some questions you might want to ask somebody.
I already have a snail. Okay, fine, fix my shirt.
What's slanted?
Slanted, straight.
Let's start.
Least street, least street,
Hot eye.
Hands are shaking.
I could just be hot, so
Daddy for Patty. No, it's
Alright.
He's like, you too.
Okay.
You got it.
Alright. So, with these new free body diagrams, does anyone have comments or questions about someone else's?
Kimberly's.
Copy.
So that's the direction. The left will be the negative.
Okay, so basically, Patty is pushing in the negative direction, and Lester is pushing in the positive direction. And they're both the same lengths, so they cancel out to 0 when you add them up.
Okay.
We got normal force and gravity.
Oh, good.
Someone else had a comment or a question about someone's.
Daniel.
Daniel.
Why'd your group draw it like that?
I just drew it like that. It's similar to yours, just, you know, I meant to do it over here, but
It's the same thing.
yeah.
It's essentially the same thing.
I just thought
Positioning one.
hidden message.
It's pretty. I think I spelled that right.
So in Socratic seminars, are we allowed to involve teachers?
If you'd like to ask me a question.
Can we do it right?
That's a little too explicit for my taste. Instead, I like to direct you back to Kunsuk's earlier comment. What did you gave an iteration of Newton's third law, which was
For every action, there is an opposite and
and
equal reaction.
so the question that
Not for me.
Yeah, that's what I was Didn't he say two body diagrams?
so can maybe. Oh, do you have a question?
No.
comment? So maybe if somebody would like to
Actually,
take
I have a
take a
question.
yeah.
we have to have 2 free body diagrams.
Yes. Maybe somebody would like to help us identify what the act. Yes.
I thought we could put them into one.
How many objects do we
Check it out.
have?
2. That, then we have Cotty going that way and Lester going that way, and they equal each other out.
But remember,
What we did.
but if we combine those into one, remember what we did before we erased it?
No.
It was like, I mean, some people had
We still have it right
the
here.
dot and then equal, right? Since they're equal, if you just combine it together, it would actually be the same thing.
Yeah. That's what I'm saying.
Yeah.
If you just shift the dot in the same position, it'd be, That's my observation.
But when we split it,
They cancel out.
Essentially.
Ooh.
It's not FB, it's FK.
So going back to Kunsuk's idea of the
Force Cotty.
I made that.
if for every action there's an equal and opposite reaction,
It's my idea.
would somebody would like to help identify what the action reaction is? Kunsuk had his hand up. Could you?
Oh, I mean, unless somebody else wanted.
Does someone else want to?
monopolize?
Yeah, Kunsuk said it had a few comments. Does someone else?
Explain it. Explain what that statement means.
I would like someone to take a leap and try to identify the.
Ford had more
no.
force than the Barker, so that's why it stopped.
In reference to your boards, I would like an
Go
action and
board.
reaction.
I'm not
But
even
it's
mad.
true.
Okay.
I say
Yeah.
like going back to our situation when me and Lester were pushing against each other, like I say my action was the push against him, but his reaction, like the reaction I got from that was his push that was opposing. I mean, I don't know, like
Okay. So did you guys get that?
Unless
Okay. So let's
I was
so
taking a stab at
let's.
it.
Connie, would you say that one more time? Because I think some people were unable to hear that.
Okay. So going back to our situation when I was pushing, I'll say my push against Lester's was like the action, and the reaction I got back was his push was the same, was trying to equal that out, and it did. It corresponds on the graph.
Okay. So if I gave you this blue pen, could you put an X, a blue X, on the 2 arrows that are the action and reaction forces?
I'd say an X on the arrow. So
Yeah, on the arrow.
you like
Could you?
oop, might as well.
So wait,
Wait, it looks like the arrows are touching, but
Yeah, they are.
what do you
okay.
mean by inaction?
So yeah, just X the arrow, the body of the arrow.
Oh, body, so X.
Mark it. Yeah.
That's
That's what I mean. Yeah.
that's action.
I'm sorry, that pen is not very good. Let me
Mr.
see here.
Henderson, what do you mean by inaction?
What's this one?
Yeah.
Actually, reaction.
Reaction.
So you said your force on Lester and Lester's force on me.
Yeah.
So would you label those 2 arrows?
So yeah,
He
that
said
one.
inaction, which means no.
Action. Oh, circle.
That's fine. Okay. So
Oh,
let's.
circle for action.
Okay. So can you hold this up so we can see? So this is.
right?
Yeah. So this is an illustration of what Cotty had experienced, where
And that's action, reaction.
The circle.
Or vice versa. One's, it could go both ways
In this situation,
in this situation.
But it's Cotty movement.
Good class, guys. I learned a lot.
right.
It's great.
or in this case, my dots too.